हरि करना।
So now let's look into the one more important uh, test and algorithm. So that is multi-arm bandit algorithm. So let's understand a multi-arm bandit algorithm in detail. So multi-arm bandit is a type of online learning technique that deals with the exploitation, a trade-off problem in decision making. It's used to maximize the total reward in a sequential decision making process. The basic idea behind MAB, that is in short, for multi-arm bandit algorithm, is to allocate the available resources such as time, money, or personal or multiple options called arms in order to maximize the total reward. So the multi-arm bandit algorithm is a class of reinforcement learning algorithms that aims to find the optimal action among several alternative actions or arms in a repeated decision making problem. The problem can be formulated as follows. So one example, let me write it down here. So this time it's a MAB, that's multi arm bandit algorithm. So let's write one problem statement. Problem can be formulated as follows. There is a set of k dollar arms, each associated with a random reward distribution with an unknown mean. So at each step, $t arms, at each step $t, the algorithm selects an arm to play and observes a reward from the chosen arm and updates its belief about the mean of the reward distribution of that arm. So the goal of this algorithm is to maximize the cumulative reward obtained over a fixed time origin. This is very important. So goal of this algorithm is to maximize the cumulative reward obtained over a fixed time horizon. So there are several variants of MAB algorithms, but the basic idea is to balance the exploration of uncertain arms and the exploitation of promising arms. One popular algorithm is epsilon greedy algorithm. I'm just writing the algorithm name. One popular algorithm under this is epsilon. It's we have to write in this way: epsilon greedy algorithm. This is widely used. So what it does is, which selects the arms with the highest empirical mean reward. That's what it will do. So it selects the arm with the highest empirical mean reward. It will take the highest empirical mean as the reward with the probability $1 minus epsilon dollar, and selects a random arm with probability epsilon dollar. So another popular algorithm in this is UCB, which is upper confidence bond. Upper confidence bond. So that's what called UCB. So in this algorithm, which selects the arm with the highest upper confidence bond. That's it. The difference between algorithm is only based on how that highest arm is selected. Here the highest arm, it selects the arm with the highest upper confidence bond, which balances the empirical mean reward and uncertainty of the reward distribution. These are the two algorithms. One selects the arm with the highest empirical mean reward with the probability, with this amount of probability, and second one selects the arm with highest upper confidence bond, so which also balances the empirical mean reward and the uncertainty of the reward distribution. So these are the two different types of different types of algorithms which are under MAB. That's multi-arm bandit. So the multi-arm bandit algorithm involves balancing the exploration of new options and exploiting the best option so far. So it's particularly useful in situations where the available options have unknown reward distributions and the algorithm needs to learn from the data to find the best option. That's why we call this as a we call this as a reinforcement learning. So MAP is the reinforcement learning. So there are two types of MAP algorithms. Okay, one is stochastic and second one is adversarial. So stochastic MAB algorithm, stochastic multi-arm bandit algorithm assumes that the rewards of each arm are drawn from an unknown probability distribution, while the adversarial MAB, that's multi-arm bandit algorithm, assumes that the rewards are chosen by an adversary who tries to minimize the total reward of the algorithm. So the most common MAB algorithm is the epsilon greedy algorithm. So which is stochastic algorithm that selects the best arm. Obviously, epsilon greedy algorithm is a stochastic MAB algorithm. if it is stochastic algorithm, it depends upon the probability. So that's why the best arm, it selects the best arm with a probability of 1 minus epsilon. 1 minus epsilon. That's why we call it as epsilon greedy algorithm. And a random arm with a probability of epsilon. So best arm is 1 minus epsilon and a random arm with a probability of epsilon. Another popular MAB algorithm is the upper confidence bound algorithm, which balances exploration and exploitation by choosing the arm with the highest upper confidence bound. So famous applications of the MAB algorithm include advertising, recommendation systems, and clinical trials. So now let's see simple example before we wrap up this MAB. This is pretty advanced. So let's consider an example of how a multi-arm bandit algorithm can be used in the context of advertising. Example: so suppose a company wants to determine which of two different ad designs to use for a new product launch. So they decide to use multi-arm bandit algorithm to allocate traffic to each ad design with the goal of maximizing a click-through rate, CTR. Okay. So now what we do, so now our agenda is so we want to use the multi-arm bandit algorithm to allocate the traffic to each ad design, and with the goal of maximizing click through rate. This is CTR. So now we'll set up the algorithm with two arms. So now the first step is to set up algorithms with two arms. Is nothing much, or ad designs, and randomly allocate traffic to each arm at the beginning. That's how we begin, at the beginning. As users interact with the ads, very important, with the ads, the algorithm begins to learn which ad is performing better in terms of CTR. So then, as the algorithm collects more data and more data, as the algorithm collects more data, it adjusts the allocation of traffic to each ad design in real time to maximize CTR. So if one ad design consistently performs better than the other, the algorithm will allocate more traffic to that ad design. So over the time, the algorithm converges to the ad design that has the highest CTR, allowing the company to confidently choose the best ad design for their product launch. So conclusion, or the, I'll say, result, over time the algorithm converges to the ad design that has the highest CTR, allowing the company to confidently choose the best ad design for their product launch. So, of course, in practice, the multi-arm bandit algorithm can be applied to a wide range of decision-making problems beyond online advertising, such as clinical trials, website optimization, and more and more.